guess Mary knows that we're starting a broadcast. Okay, so the Hangout on the Air is now live, and we're talking about the requirements for the general modeling grid for the structural modeling approach. And what we have on the screen now is a display of the general modeling grid with some with a system partially filled out. And I'm using Firefox and Selenium IDE to automate and drive this particular set of interactions with this website. So what I'm going to do first is I'm simply going to run the test suite so you can kind of get an idea for what the overall system does. It'll go really fast, and we'll talk about it a little later. So it's basically now just this recording of structuring the system. You can see the common ones down below, the 3 and the 6, the 7 and the 9, 8 and 11. So this one, I think this one is strictly ordered. There's no common ones, so in this particular one. So did that make sense to you, Kevin? What's going on?
This is a recording of entering data into the program?
Right. So yes, this is recording. I've recorded all the actions, and then all I'm doing is playing it back now.
So after you put in data for one of the rows, it's then calculating and sorting to get a lower triangular?
Yeah, so that's exactly. So it's kind of a couple of things are going on. And the lower triangular piece is very important because we know when we're all done, we're going to have all the ones in the bottom in this case, and all the zeros in the upper triangular. And so that's what it's doing. So let's just do one here. You can just start a new one. Okay, so let's do one of size, let's say 9. There's our matrix. And so then we have initial matrix size, it says is 9. And are the entries equal? And in this particular case, the default setting is no, which means they essentially are not clustered, or they're not the same. And if you put a Y in there, that means yes, they are the same, and you can use it for clustering. So it's the equals entry equal piece basically in this case means it's a symmetrical relationship. So let's say, for example, we say that yes, they are equal, and we say 1 and 6, right, are equal. And so what it does is it leaves the 1 row, but it takes out the 6th row and column and puts them down here. And then let's say we have...
Could you repeat that?
Okay. So essentially what we did up here in the...
Just repeat it from when you put in column 1, row 6, what happens?
Oh, when you put in column row 1, 6, see, what happens is that as you can see right here, we have a 1 that's kind of a tan wheat background here down below. We have a white 6 next to it. And you can see here we have a 1 and a 1. So the 1 now represents not only 1, but also represents 6. And you can see here between the 7 and the 5, and the 5 and the 7, that there is no 6. So the 6 is now being tracked up here in the 1, and this shows us that 1 and 6 are the same. Does that make sense?
Yeah. I was just, so this is for clustering?
Right. So right now what I'm doing is I'm going through the Handbook of Interactive Management. And in the appendix in the back, they have the description of the GMU ISM software and all of the commands that you put in, and then the responses from the computer.
Yeah.
And it has 3 commands in the back. Do model, which is the most general, do cluster, and then do priority.
Okay.
And so this one right now, what we're working on right now can go, we can just, if it's all clustering, then we can do a cluster on it. Or if it's a priority structure that has some things that are the same, we can also do a priority structure.
Okay.
What I haven't done is I haven't checked it out completely on the do model for the non-symmetric type of natural language relationships like influence. Right?
Yeah.
Like influence can be symmetrical in some cases and asymmetrical in other cases. So that's basically what happens here.
So can you go to a priority structure and show me a few entries and what happens?
You know, I can sure I can do that.
You do that by going entries equal n. Is that right?
That's true. So just let me start over. So we're going to do another one of size 9. And then see entries equal n, right?
Yeah.
So now we'll say that 2, say, is higher or is north of or higher priority than 4. Okay?
Yeah.
Enter. All right. So now we have the 1 in the lower, right?
Yeah.
And the 0 in the upper.
Why does something happen in the upper triangular?
Why does something happen there?
Yeah. Why is it turn red?
So the 0, right? The 0 itself has 2 meanings depending upon its background color.
Yeah.
So the 0 with a yellow background means unknown.
Yeah.
And a 0 with a red background means known false.
Is that because you didn't say the entries were equal?
Exactly.
Okay.
So we know that if we're doing a priority structure, which is asymmetrical, right? So we know that if 2 is of a higher priority than 4, then 4 is of a lower priority than 2.
Yeah.
All right. So let's go with 3, right? Let's say 5. And these now are not equal. Okay. And we basically have the same thing. So we have green in the lower, green 1's in the lower, red 0's in the upper.
Yeah.
So now if we go with, well, let's say 7 and 4. Let's see. Let's go 7. Go 9 and 7. Let's do that. Now we can see that the green 1 is in the upper triangular. The red 0 is in the lower triangular. So what we're going to want to do here is we're going to want to swap those entries to align them properly. So what happened here is we've swapped row 9 and 7 and column 9 and 7 to put the 1 in the right place. That makes sense?
Um, no, I don't.
Hear anything?
I see. I see. I was reading, even though it said enter column number, enter row number, I'm so
Right.
used to the convention of row column order that I was reading it row and column, so it confused me.
Okay. Yeah, and so this is something, this interface, the way it works,
Yeah.
this is something that we're going to need some user requirements on, so that, and maybe the idea of a column number and a row number, maybe that's not even the right title. Maybe it's object 1 and object 2. Things like that.
Right.
So,
Okay. Okay. So now, can you put in an entry that connects a couple of these so we can watch the inference?
Okay, let's see. Let's see what could we do. Let's go 4. Try 7 and 4. I'm not quite sure how that's going to work out. Okay. So now what we need to do here is we need to swap these. And we see that we have the 9 is in the upper triangular, so we're going to need to swap that one. Now I'll see if we can get some there. There we have inferred information.
What's the blue?
The blue background means inferred true. 1 is true. Green is empirical true.
Okay.
We know that by asking information. Blue background is inferred true.
Okay.
I've got a question here.
Sure.
And this would be addressed to Kevin, I guess. Would it be more obvious what's going on if we actually had a legend for the different colors and numbers as part of the screen itself?
Yeah. I mean, I think you need a legend.
Okay.
Excellent. We can do that.
Yeah.
See, that's one of the problems, Kevin, is I'm so close to this. I don't see these issues, and that's why I need to start working with someone that's not as close to it as I am, the software, but understands the process. So I appreciate your help.
Yeah. I think you might want to have an option before you start of whether the system automatically swaps entries or not. And you might want to have 2 matrices being tracked, one with the original order, just ordinal, ordinal count, 1
Right?
through 9, and then a second one that handles the rearrangement of the rows and columns, because from an input standpoint, you can't. It's difficult to track the reflection of the input in the matrix if the rows and column numbers are changing.
So,
You take it with a grain of salt too, because the packages that I've seen don't show the matrix at all during the input phase. So this is this
well,
is this is offering something unusual for compared to packages that I've seen, and so I don't want to put too many requirements on it. I'm just
well, you've hit the two major things that I think needed to be done next. Okay, and besides, I think we need to work on the just on the labeling. Actually, it's three major things. It's the labeling, put some color legend in there. But what I'm doing now, and one thing that is the idea of, in the past, traditionally, the mathematics and the way this transitive embedding seems to have worked was that the matrix was static, and then you did all the mathematics and generated these tables.
Yeah.
And then from the tables, then you generated either a new matrix or you generated the graphs from the tables.
Right.
And in that case, the matrix was static with information going into it.
Right.
In this particular case, we are dynamically changing the matrix.
Yeah.
And when we're dynamically changing the matrix like this, then it makes a much closer connection to sorting and searching. That's standard algorithms in computer science.
Yeah.
And
I think it's valuable to have the dynamic updates. I'm just thinking that if the interface, if the representation of what's going on is the matrix, you might want to have both an original ordering as well as the dynamic update. I'm not sure. I'm just saying that it's the simple act of seeing where the number shows up when you put the row and column in, and where it is in the matrix gets confusing if you're just looking to see where in the matrix the number shows up, which is a trivial thing, but you can't easily track it according to the row and column indices.
I agree.
You know what I mean?
And so so the idea about automatically updating the swapping, that's the next algorithm. That's the next method I'm going to add to the algorithm. It's
Okay.
to the software.
Yeah, sure.
I have to finish writing the unit test for what I have now. Then the automatic swapping is the next thing.
Yeah.
But what I've been doing and kind of got caught in a little bit is the fact that the transitive embedding process itself is presented in terms of a static matrix. And then you do the inference and you search and you look for the highest inference potential within a static matrix configuration.
Yeah.
That appears to me, when you look at the same operation, one is a static matrix with transitive embedding. The other one is the dynamic matrix with binary search or sorting, some advanced sorting techniques. But they're essentially doing the same thing. And so putting them side by side like that would be very interesting, especially on larger matrices, to see which was the most efficient, and so that you could find out which method would take the least amount of empirical information. You've gone exactly to the places where I think we need to go next. And that's, I'm glad we're in agreement on that. It's good.
I think there's a dependency on the problem space, and it might be a kind of a user interface decision that people make when they start this, which is there's kind of let's say we can divide the world of inquiry into two different situations. One situation, in one situation, you know a bunch of pairs that you'd like to confirm a relationship in.
Mm-hmm.
Then there's some you might not have thought of, and to complete the analysis, you'll go through it. But there's other situations, and the majority of the policy types ones that I've been involved with, you don't have any for making relationships, and so you're completely open to just sampling, right? And in that case, it makes sense for the computer to sample what to try next.
Right.
So I think there might be, and that might mean that there's, depending on which situation you're in, you might prefer two different interfaces. And I'll give you an example of the first one I talked about. Like if you want to, suppose you're reading, suppose you want to develop a model of an ecosystem, like the food web in an ecosystem,
Mm-hmm.
and you're gonna do it from literature and biology. So in literature and biology, you'll find predator-prey relationships expressed, right? So this guy, the fox eats the mouse, and
Right.
the wolf eats the fox.
Energy turnover rates.
Right. And so in those cases, if you've gathered up a lot of causal relationships,
Uh-huh.
then you want an interface where you can express the specific, you can enter the specific relationships that you know about. And then after you've put in all the stuff, all the relationships you know about, you'd like to know, the computer can tell you which other relationships can't be inferred yet and need additional study. And so it can point you to either to continue your search or to have a dialogue and come up with your best answer that you can for now, or to just say, this is the horizon of research that we need to look at. On the other hand, a different situation is if you really have never thought about this before, where there is no literature, or it's such a fresh situation that everybody's new to it, then putting in the row and column numbers is really a little strenuous for that situation, because you want to just be guided through doing it. You see what I mean?
Yeah, so it's, again, I think I'm really glad we're having this conversation, okay? So I refer back to the handbook on interactive management and also the mathematics of structure. We're talking about transitive embedding. And to address the different approaches given the different situations that you talked about,
Yeah.
first of all, within this modeling grid and the structural modeling we're looking at right now, we can't add anything to this matrix. The matrix itself is the biggest it's going to be when it starts. We can make it smaller. If everything is in one group, we wind up with just a matrix of one, right? And that's it.
Yeah.
So in the coupling method within the transitive embedding, you're able to address the scenarios that you talked about. you're able to actually take two matrices and couple them together. If you've worked on some things and you have some information, and you have a matrix that's ordered, and then you have some other new information, the coupling procedure allows you to make a bigger matrix. And that's the transitive embedding piece and one of the benefits of it that's not really available yet in this software or in this method. So that's a key point.
Yeah.
But the problem with the coupling method is you have to have two matrices that are ordered. And when you look at these scenarios that you talked about where you just go in and you really don't have hardly any information at all, then that's what they call the scanning method. You go through and then you just take a first cut. Like in this particular case, we'd go through and you would just scan the relationships, just do a 1 and 2, 2 and 3, 3 and 4, 4 and 5, or 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8, something like that. But you would just get the information on a wide range of your data, but that covers the whole matrix, right? And then you break it apart into two matrices, right? And now you have the basis for the coupling method. And determining when to do the scanning method and when to do the coupling method, or the bordering algorithm, that's another one you can do. Those are kind of right, and those are the things that I'm trying to address from a software architecture point of view right now.
When to do bordering, coupling, or what was
Scanning.
the third?
Scanning. Yeah, scanning method. Yeah.
That's something I'm going to have to spend a little time reviewing. I think another point I would make is that maybe it's for the scanning method, I'm not sure, but the numbers that are in there, the one, in this case, 1 through 9,
Yeah.
those are node labels, right? They're the identity of the nodes.
Yeah, they're just they're name tags. They're name tags. That's all they are. They could be.
Yeah, they're name tags.
Right.
They're not necessarily the order you might want to do something.
Exactly.
So you should be able to tell. Suppose you took a vote on 1 to 9 in a group of people, and they decided that item 3 is first, 5 is second, 6 is third, in terms of what they want to consider, because they want to spend their time on what's most important to them.
Right.
So there may be an array, just a one-dimensional array,
right,
that has the preferred order for the computer guiding what to ask about.
Right.
And
so that was, I think, an example like that is in the appendix in the Handbook of Interactive Management.
Okay.
And so that's kind of the what I'm working on, and matching this software interface and the answers that come back from the computer to that particular software description. So they have a clustering one there, and they have the do cluster and do priority. And the do priority basically is just a irreflexive, asymmetrical, and transitive relationship.
Yeah.
So we're working with that, and yeah, so those, and then we need to work the interface. And one of the things is, you think it would be valuable to have one user interface, like for doing clustering or doing symmetric relationships, and then have another another interface for something that will do just strict order, and then another interface for something that will do general order, which is a ordering that allows multiple things at one level. Because when I use the matrix now, I know what all that means, so I use it differently. This is just the fundamental demonstration of the software.
Yeah. I haven't thought about those distinctions with respect to the interface, Joe. I'm gonna think about that. Let me write that down as another thing to think about. So, distinct user interface for priority structures versus clusters, and what's the other one?
The do model, just the general one. It's just the 3 commands out of the GNU ISM software.
Okay.
And that's all listed in the back of the handbook.
I haven't really thought about that, and I have to give you a caveat because I don't think I've ever seen a cluster application.
Okay.
And the I've also never seen a graphic interface for a priority application.
Okay.
I have used the GMU software going back to 1994. 94, 95, I used the GMU software, and I don't remember a difference in the interface because it wasn't a graphic interface.
You're right.
DOS program without using Windows. And
yeah, I think you're right. In fact, I know you're right there. But they had the 3 different commands. And
yeah,
so
I understand that. It was, but the the difference in the interface is what it ended up asking you to enter. It didn't present a different screen because it was a command line interface.
Yeah, so in the do cluster, where it says entries equal question mark here,
Yeah.
that would be that would not be in a clustering interface because that would be yes all the time in a cluster.
Yeah.
It would be yes, they're the same.
Right.
So then you would get different categories. It would give you 4 or 5 different categories of things. I think in the handbook he talks about categories of items, movies
Right.
and buildings and things like that.
Right. Yeah.
And so, but in the strict priority structure, right? The strict priority structure, that wouldn't be there either because it would always be no.
Right.
Right. And only in the general priority structure, where you could have more than one thing, would you have that particular data item required.
Well, the other way it can show up in the general model is if you're just kind of methodically going through different combinations, and
right.
when you've confirmed there's a relationship of 9 and 7, so that's a yes, right? But and then you go on, and later you inquire 7 to 9, and
right.
maybe you decide yes there, and maybe be in the mode where when you admit up front that you don't really know anything and you just want to explore things robustly and have a deliberation about each point, then you don't know if the entries are going to be equal. They might end up being equal because you happen to ask 9 to 7 and then later 7 to 9, and they end up being equal. So
that's true, but in this particular case, we're talking about an asymmetrical relationship for the priority structure. So,
well, I was talking to me in the general model.
Yeah, I don't have a general model here, but yeah. So if we if we did a general model, I'm trying to see, how that's going to work out, right?
Right.
I've done the clustering one, I've done the priority one,
Right.
and so the general one is, I think I'm going to need to maybe add some to this, but I'm not sure yet. So
Yeah.
we'll see.
Okay. Yeah. So that is helpful to me because I didn't realize this was just focused on the priority structure.
But no, this is when you when it says entries are equal.
Yeah.
When it says entries are equal, that means it says that no, they're not equal. Then this is an asymmetric priority structure.
Yeah.
Or
Well,
basically,
what happens if you have n, 9, and 7, and you enter the data like you just did, right? So
right.
I'm looking into the matrix, column 9, row 7, column 9, row 7. Oh, column 9, row 7. Okay, so I see where it's been entered, and um, and then what happens if you now say 7 to 9?
Um,
Does it reduce it and make the cluster?
no, that would right now, without any validation on the front end of that, it would probably just switch them. This particular software will do what you tell it to do, the way it is right now. So you would break the logic if you did that. There's no checking to make sure that you're only putting in asymmetrical pieces, right? What I think I hear you saying is, to do a general model, and I'm glad you're saying this because it's helping me think about how to do a general model based on this. If we have one and then later on we come back and do the other, right?
Yeah.
Then that should make it equal. So make those two equal, and we need to know what that means in this specific modeling process. So I could put a flag in there that says, it goes one way, and then if later on it came back the other way, then we do something else. So that's interesting.
Yeah.
Good idea. Good idea. Hopefully that made some sense.
Yeah, no, it makes sense. Yeah.
Yep. So I think, let's see. What I'd like to talk about a little bit is how would you like to participate in the conference in November there at SIGO?
You wanted to talk about the value of open software, right?
Right, open source software, right.
Right.
And so
What is the date of that?
that's November 11th.
Okay.
I sent out a link on, I think you probably got it. So it gives the calendar and the date. I'll be, I think, right up after mine talk is right after the plenary
Right.
on the first day, on Friday. And so if you could hook up by video, that'd be great. And we could have a video recording stashed somewhere on the web in case, something happens, or I can have it on a stick or something. So
Okay.
got multiple ways to get it there.
What will we be in Hangouts?
Well, no, I don't know exactly how they're going to handle it at the conference. The conference, they said it's going to be recorded, and they're going to do it somehow, right?
Okay.
But if I have my computer and I'm there, or if there's a computer that's there and you have a video and I have it on a stick, right?
Yeah.
Then I can introduce you and you can say whatever you'd like to say, and then I can comment afterwards.
Okay. Yeah, well, I think when we were identifying the objectives for the systematic review paper, we started with the objectives of the overall project, which most of those objectives had to do with objectives of open source software.
Okay.
And I mean, I first started looking at open source issues with respect to publishing in general back in like 2006. I haven't been involved in an open source software project.
Well, I think the thing that is interesting.
And go ahead.
Yeah. So the thing that's interesting to me, and I think the thing that will be interesting to the people at this conference,
yeah,
is the fact that this approach has been around for 40 or more years, and there's been a lot of closed source applications. People are still finding it very intriguing, like that psychologist in Ireland,
yeah,
you know, who's basically pushing the 76 book as the roadmap to collaborative intelligence in the future.
yeah.
But the reason that one of the difficult things about it, and to make that happen, we need to have open source software so everybody can see what's going on, understand it, build their own software if they want. And that actually closed source software in the past has really, in my opinion anyway, has really kind of slowed down the understanding and the spread of the technique.
Yeah.
So that's basically what I'm going to tell them. And that fellow with the Psychology Today article here just last month was just perfect.
The guy had an article in Psychology Today?
Yeah, I thought I sent it to you, but I'll send it to you.
You might have sent it to me, and I just didn't realize it.
Yeah, just last week. There's this fellow is basically a cognitive neuroscientist, works for the university there in Ireland, and works for the European Union. And his first statement right off the bat is Warfield's approach for societal systems basically is the way to go. It's been out there 40 years, and it seems to be one of the only ways it's going to help us out of drowning in all this data. Because we're using computers against ourselves right now. He goes into quite a lot of detail.
Yeah, I came across that guy. I think I came across that guy's article a couple of years ago. He was at Harvard and did something with structural modeling.
Ah. Well, anyway, it looks like he's working with Ben Broom.
Huh.
Some of his articles are published with Ben, I think. Speaking of Ben Broom, did you see that document on the interface that I sent out?
The document on the interface? I downloaded documents you sent, but I haven't looked at them from the last few days.
Okay. Well, anyway, so there's a detailed document there where Ben Broom goes through the 5 steps, the 5 phases of doing ISM. And he has screens, computer screen information type of organization.
Yeah.
And so I think that's one thing that I'd like to get some feedback on. Is this a good approach? Should we try something like this? because the fifth step, of course, is the structuring that we're doing. There's 4 steps before this, right? Getting the question, people talking, dialogue, voting, all that, before you get to this fifth part that we've been working on. And so,
Right.
so yeah, that's kind of what I'd like to also get some input and some feedback on that, because if there is some interest at this conference, things could change real fast.
You think so?
Oh yeah.
Why do you? So, what is the insight you have about a latent interest in structural modeling?
Well, no one is better equipped to understand the volumes of data that human beings are drowning in than these open source people, because they live with it daily, right?
Okay.
And they're intimately familiar with the fact that computer tools like big data and huge search and all this stuff doesn't help human beings have any insight. It's just data. And it doesn't matter if it's a small amount of data or a big amount of data. Using the stuff that they do, people just argue about what's right and what's wrong. And as this fellow Hogan, I think, talks about in Ireland, that this approach, the structural modeling approach, allows people to incrementally learn and understand and interact with the data in a way that's more scoped to the human intellect.
Uh-huh.
So yeah, I think there's a good possibility that there'll be interest there. But you never can tell. If not, I'll just keep hacking away.
Did you order get it?
Hello?
Yeah, I'm here, Joe.
I just thought I heard somebody say something.
Yeah, my wife just walked in.
Oh, okay. Well, anyway, so I think we covered most of the major pieces that I wanted to talk about. Is there anything else you'd like to talk about?
Well, I just want to mention to you that I started a course with the Santa Fe Institute
Oh,
on
good.
complexity sciences on agent-based modeling. And
Yeah.
I'm attempting to do an agent-based model of structural modeling.
Okay.
So instead of using matrix algebra, it uses graph search techniques.
Right, yeah.
And every idea that comes in to join the graph has its own program to figure out where it belongs.
Yep.
Because my longer run interest is to develop a distributed, decentralized approach.
Yep.
So we can do large scale stuff where there may be multiple matrices going on in parallel, and then they end up joining.
Right.
No.
You know, that's if you look at the art construct,
Yeah.
where the multiple matrices that are integrated in different ways.
Yeah.
Some numbers, yeah, that's it. Just got to get the basics down and move forward. I think the agent-based piece, where you're having local rules and you're having local values and local decisions made.
Yeah.
So we do I don't know if you, a couple of the papers Mary and I wrote, we essentially laid the foundation for something like that in the art framework, where we do a global space, then we do local spaces.
Oh.
And the change in either one of those spaces or in its context located on either contextual rules, global rules, or local rules, interfacing with each other. So.
Oh. Did you send me the links to those papers?
Sure.
Yeah, I'll try to figure that out. I haven't done any programming in many years, so
Hey, well, if you want to kibitz and talk, man, just let me know.
Okay.
Call me up. We'll, there's,
Because this language is called NetLogo. It's based on Logo, which was based on Lisp at one point.
right.
Well, NetLogo was based on StarLogo, which was written for the connection machine to run in parallel processing.
Right.
And then StarLogo was written in Logo by Seymour Papert, which was written in Lisp. And so I haven't really engaged programming in a long time, but I've had this idea that when we're doing these inquiries, that every idea could be its own object, its own agent, and its goal is to find out how it relates to all the other ideas. And it's kind of an inversion of all the approaches I've experienced, which is you have a bunch of people in the room and they put all the ideas on the table and you start to create a singular matrix about the relationships where all of them talk and decide together on what their votes are. And what I'm interested in is a more distributed approach. What happens if two people just decide to talk about a particular idea?
Yeah, it's
How they relate to each other, or two ideas and how they relate to each other.
it's very interesting times right now with the technology and the ideas. And besides just the technology and changing form in the technology, or changing the ideas and how they're expressed because you're using a different technology, one of the things that I wanted to talk with a psychologist fellow about is actually, are there simple tests that you can use with human beings to figure out that, this is a symmetric relationship, this is asymmetric? Because when Warfield talked about an adjacency, natural language relationship adjacent to, I thought it was non-transitive. But he was using it as it was transitive. It takes a lot to figure that out. And so there's just these basic, are there fundamental tests that you can, have someone take on a computer screen for 3 or 5 minutes or something to calibrate how they're thinking about, these basic relationships. I think that's another area that's really important and can be fairly easily done these days, I think.
Yeah. I haven't seen software that asks if it's symmetric or asymmetric. I've only seen software where you confirm it you confirm the relationship between two nodes in one direction, and then you might confirm or deny a relationship in the opposite direction later on. And then it becomes symmetric if it does. And,
yeah, so that's basically the way it would be done.
But it might be, I don't know if people actually think like that. It might be that when they're presented with two ideas, they might more naturally think if they're interrelated or they're the same because they're synonyms, or they're asymmetric, and then which direction are they?
Well, that's really interesting. There was a fellow on the one of our projects, one of our advanced projects, who was a software guy and he was a hardware guy and he was an architecture guy who was very talented. And he was running a team of people, and he was using all the different graphical languages that that groups of engineers used.
Yeah.
So the software engineers used UML, and the hardware engineers used IDEF0.
Yeah.
And what he found through his series of studies, I think he got his doctorate's degree on this, or a second doctorate's degree on this or something, but that people actually, that software engineers more naturally think like the nodes are the functions and messages passed between them.
Yeah.
And mechanical engineers naturally think of the big physical blobs being the nodes and then other stuff passing between them. And there's a whole series of literature out there about fundamentally just difference the way people think. And I'll send you a link to that paper too.
Yeah, that'd be good.
Because if you can find out with some simple tests how people naturally think, integrating some of these aspects to them. And basically, I think the bottom line was, well, that's why these people become software engineers, because that's the way they naturally think.
All right.
So anyway.
I look forward to that. Well, it's a good set of things to follow up on for me. About a half a dozen for me to follow up.
Okay, well, Kevin, thanks for your time, and I will look forward to talking with you on the 1st or beforehand if you got any questions about that other software.
The other software?
Yeah, your net logo and your agents and so forth.
Right. Okay, Joe.
All right, take care. Bye-bye.
Take care.